And our fourth participant is Joanna Stuszewska. She is an expert in numerical modeling of air quality and climate in the IOP-NRI, and she will be representing and presenting to us the project, the live project REMAI. So please, Joanna.
Thank you very much for the invitation. So waiting for my slides, I would like just to remark that our approach is a bit different than we have heard so far, because we are dealing mainly with modeling and the preparation of crucial input for modeling. So these are emissions. Our project just started in beginning of May this year. So I will present mainly objectives of the project and how we would like to proceed. Next slide, please. So this is a preparatory project, which means that we address some special needs which are connected in CAFE directive. And in CAFE directive, modeling is mentioned as a supplementary method of obtaining obtaining a spatial distribution of pollutants. So we can use measurements, and in some places we can also use modeling results. And of course, modeling results are highly biased with the quality of emissions. And emissions are rarely measured. These data are estimated, these data are historical. So the question that is raised is, to what extent the uncertainty of emission inventories impact the results of air quality modeling, especially in terms of air quality improvement plans. So there are 6 institutions, and the project is led by Terraria from Italy. And next slide, please. Next slide. Thank you. And the project objectives. We would like to support modeling groups with some recommendations concerning how to prepare emission data and how to use emission inventories, especially in the case when we have local inventory and regional inventory, and there is a need to compile different type of data sets. Our aim is to assess uncertainty of emission factors, especially for traffic sector and for residential sector, because in many countries these 2 sectors are dominant. In the case of traffic, this is mainly for NOx and NO2, and for residential sector, there are large uncertainties in terms of PM 2.5, PM 10, and benzalpha-pyrene. So in general, we will issue guidelines, and this will be based on the modeling, source receptor modeling, and also deterministic modeling with the use of regional CTM and urban models. Next slide. We will address 3 different regions in Europe. One is in Catalonia with a special focus on Barcelona. Another region will be Po Valley and a special focus on Milan. And third region, which will represent Central European condition. This is southern part of Poland, which is a highly polluted region with a special focus on Krakow. And of course, we will address also a regional scale modeling. There are 6 actions, and 3 of these actions are dedicated to modeling. So one action will deal with emission uncertainty, another with the integration of different spatial information, And this will serve as an input for urban modeling, regional modeling, and source receptor modeling. And next slide. And our expected results, we will prepare a web portal which will offer an option to relocate and combine different emission data sets, and also set of recommendations concerning compiling and processing of emission data sets. So we will address this to modeling a community and also to people dealing with emission preparation and emission factor assessment. And next slide. And we closely cooperate with FERMOD. This is a forum on air quality modeling in Europe. So this would help us to disseminate the results among European community, and also some territorial boards will be formed in Spain, Italy, and Poland. And then we hope to disseminate also the result among other experts from other countries and regions that are responsible for preparation of air quality improvement plans. Thank you very much.
Thank you, Joanna. Our next guest is Stefan Schroeder. Is a PhD in electrical engineering, working in Sensera and managing several air quality projects from the company. He's presenting the Ulysses project. Welcome, Stefan.
Yeah, hello. Thanks a lot. Yeah, as you introduced, I will talk about the Ulysses project. And the Ulysses project, it's a bit cumbersome name, and it stands basically for Ultra Low Power Integrated Optical Sensor System for Network Environmental Multigas Sensing. And this kind of summarizes actually the objectives very nicely. Can you please go to the next slide? So there are some key facts here. It's a Horizon 2020 funded project and has started in 2018. We have a consortium of 8 partners, 2 universities, 2 research institutes, and also 4 companies. In contrast to the NanoSen-AQM project, we will not using electrochemical sensor approaches. We will use optical sensing approaches like non-dispersive infrared gas sensing. And with that approach, we try to sense multiple gases. But today I will just present some CO2 measurements. And in this project, we try to address 3 main problems of a non-dispersive infrared gas sensor, and that's how to generate light, infrared light, and then also how to minimize or miniaturize the interaction lengths of the light bars, and also we are looking into new approaches of infrared light detection. Can you please go to the next slide? So, since I mentioned, I will just present some CO2 measurements here. The motivation why we look also for CO2 is essentially that carbon dioxide is affecting us negatively in terms of our health, but also our productivity. For example, on the right side, you see some cutouts of articles. They clearly indicate that actually elevated CO2 levels are reducing our cognitive performance. So that's quite crucial in certain ways. And therefore, CO2 is an air indicator or an indicator for air quality in general. Yeah. And besides that, there are also different aspects why monitoring CO2 is, for example, to minimize energy consumption for HVAC systems, meaning the energy consumption that is needed in order to ventilate houses. But also CO2 is a greenhouse gas, and therefore it's also important to identify emission sources and act against these emissions. Can you go to the next slide? So our situation is similar to what Franz presented before, and non-dispersive infrared sensor is here shown in the center. And it's based off three main components. It's an infrared source. Then we have a light path where the infrared light is bounced back and forth between mirrors and is there interacting with the gas. And then this light or infrared light beam hits a detector and will be then converted from optical to electrical signals. And before that, the light is entering a filter that basically cancels out all wavelengths that not are interested. So if we look at the lower graph, when we put the bandpass filter, for example, around CO2 or CH4 methane, then we cancel out all other gases that could be interfere with that signal at the detector. So, and an advantage of this, can I go back, please? An advantage of this sensor is basically that it's an optical sensor, which is very fast. If it's well designed, very specific and has extremely low drift and no hysteresis. But there are also some disadvantages. As you can imagine, it's rather bulky because we have to maintain a rather long freeze path length. And one objective is also to find solution to minimize that system. Next slide, please. So the vision is basically to minimize these systems in such a way that it can be fitted into some kind of wearable gadgets like a smartwatch, as you can see on the right side. Another idea is, for example, if you see on the left side is our CTO, that it's measuring the air quality in a subway in Brussels, and look just at this at the app, how the air quality is stated there. And in the center, you see basically the schematic illustration, how the sensors should look like. We have an infrared source, then we will have a guided path where the light can interact with the gases, and we have several detectors that will then detect the different gas concentrations. Next slide, please. So the question is how to miniaturize the system. And today I will just briefly mention the miniaturization of the optical parts. And if you look on the upper left side, you see this optical fibers, which we know that's utilized for optical telecommunication. And if we look at this cross-section of the facet and look on the right side, there are certain simulations of the electromagnetic field distribution. And we decrease the diameter of this fiber, then we will come to a point where the confinement factor is decreasing, meaning that a certain percentage of the electromagnetic field is propagating outside of the fiber. But still the fiber can be used for guiding the light. And this approach we are using in order to minimize the optical light path. And we have done that in such a way, as you can see on the lower left, we're using a suspended waveguide as an optical fiber, so to say. We could, for example, what you can see on this image there is a waveguide spiral that is about 20 centimeters long, and we could put it in a form factor of about 1 or 2 square millimeters. So on the right side, you see basically an SEM image of such a suspended waveguide, which we will use then for sending the different gases. Next slide, please. So on the left side, you see some early examples of carbon dioxide measurements. And we could discriminate different levels down to 0.1% with this approach. But I have to mention these results are based on a lab setup. This is not the results that we have done outside. Yep.
Sorry, you should be ending your presentation, sorry, because the 5 minutes already ended.
Yeah.
Sorry.
Yeah, 2 words.
Okay.
On the right side, you see some real-time measurements that we have done in the Stockholm area, and we have measured over the day certain CO2 levels. Next slide, please. So final wording also in this project is to kind of add some kind of intelligence to our sensors in terms of that the sensors are not just giving some ppm values of carbon dioxide or another gas concentration, but they should also provide some kind of belief function, meaning how accurate actually is the sensor measuring. And by this, I will finish my presentation here. Thank you.
Thank you very much.
From the Ulysses team.
Thank you, Stefan. And finally, we have two more guests that are members, partners of the NanoSen-AQM project. We have here Jesus Lozano, who's professor at the University of Extremadura, and Esther Ontañón, researcher at the TEFIS CSIC. I don't know if you would like to present yourself or something, Jesus, Esther?
Yes.
Yeah? Okay, then please, Jesus.
Okay, thank you, Olga, for your kind presentation. I would like very briefly to describe our research group that is called Perception and Intelligent System. We are a multidisciplinary group formed by electronic engineer and computer science engineer. And basically, our research lines are related with electronic instrumentation, gas and chemical sensors, and machine learning techniques. Our participation in this project, in NanoSen-AQM, is related with the development of several prototypes for air quality monitoring, the calibration of these sensors in order to a better functioning in field. And we have done also several campaigns of validation of our prototypes and to perform the data processing for obtaining the best values of these prototypes. We have another project related with also with gas sensing, in which, for example, we combine the optical measurements with the measurement of the resistance by creating novel sensors, novel transparent sensors, and measure these two parameters. And we have also other projects related with agriculture or food industry, trying to analyze the gas emitted by different products. And we have also a project related with the detection of several diseases through the breath or other fluids of human body. And to finalize, I would like to say that maybe the challenge in future projects related with air quality should be focused in two research lines. The first is the development of novel and enhanced gas sensors, because as you probably know, there are a lot of sensors with different principles of working, but there is no a perfect sensor, so each one has his advantages and drawbacks, and it is a good research line to improve these sensors. And the other is related with the calibration and validation task, and related also with the data processing techniques. As my colleague Eduardo says before, I think also that the validation of these systems is a crucial task, because if you make public some information that is not well measured, maybe it is a problem, no? And the main opportunities that we have in the future are related with the Internet of Things, smart cities, ambient intelligence, and so on. So thank you very much.
Thank you, Jesus. Esther, if you would like to say something.
Yes, well, I would like to say that CSIC, the Spanish Council for Research, is the largest national research and development center, and also one of the largest in Europe. And it has about 120 institutes distributed over the geography of Spain. And in terms of air quality monitoring, there are a very well-known group and institute, which is the Institute for Environmental Assessment and Water Resources, which is called IDAEA. Actually, this group has participated in some of the European project that has been described by, for instance, by Jose Maria Barceló, the Captor project. And they are also participating, I saw in the presentation by Joanna, that also IDAEA is participating in that. And they have participated together with many of the companies, and also with Begoña Artiñano, Franciamat, in air quality monitoring campaigns all over Spain, all over Europe, and I would say all over the world. And This group is the best group leading with the air quality monitoring. But there are other groups in CSIC and other institutes and other research groups which are more going to specific issues. No? So in the case I belong to the group for nanosensors and smart systems. And in our group, we collaborate, let's say, more tightly. We never have the opportunity to collaborate with the group I previously mentioned from CSIC, but we have collaborated quite a lot with another group, which is the Institute of Microelectronics, which is also in Barcelona, like the IDAEA. And together with the Institute for Microelectronics of Barcelona, in Madrid, our group, we develop gas sensors, mostly metal oxide resistive sensors. And we focus in the development of materials, new materials, innovative materials, in order to, let's say, to improve the capabilities, detection capabilities of the gas sensors for air quality and for other many applications. And also to reduce the size is another of our, let's say, challenges, as it was mentioned in the presentation by Stefan. And we also develop technologies for, let's say, to prepare or to deposit the materials that are interacting with the gases on the platform or the substrate that are needed for detecting and finally obtaining a signal that can be measured by any instrument. So we are more focused on the sensor, which is the key component of these air quality monitoring systems. And we also deal with the assessment of the capabilities of these sensors we develop for detecting a variety of gases depending on the application. So we have large facilities, a number of facilities for assessing the detection properties of the sensors we develop. We are also somehow connected with the applications, but this is a bit more farther away from the scope of our research. And that's the reason why we collaborate tightly with the University of Extremadura, with the group of Jesus, because they develop the full electronic systems that are needed for, let's say, to take advantage of the data provided by the sensors and to be able to give some measurements of air quality if this is the final application we are directed to. And the group I am leading is the coordinator of the NanoSen-AQM project, that is the organizer of this event. And well, I am really a very newcomer to the field of the gas sensors because I joined CSIC not a long time ago. But I have to say that from my point of view, it has been very good experience, the NanoSen-AQM, because it's not so easy, what I didn't find so far, many European projects in which the persons who, or the research groups who are involved, which are involved in the direct development of the sensors have the opportunity to first to put the sensors in a real scenario and to make the measurements, and also to be able to interact and to collaborate with the other actors, which plays really a role in this air quality monitoring field, which are the ones who develop the software for machine learning or for treating and dealing and post-processing and analyzing and obtaining the best information from the sensor data, and also the persons who develop the electronic system and the monitoring system, and the companies that has to put the systems in a real scenario and to let's say, to customize all the systems they develop according to the application and the scenario they are dealing with. So I think in this case, NanoSen has covered all what the European Union call the value chain. So we went from the developer of the sensors to the final end user, the public administrations, which has competencies in air quality management and control. And I think it's all the persons who are involved in the development of sensors should at some point to become more active also in this kind of projects.
Mm-hmm.
That's
Thank
all.
you. Thank you, Steph. Thank you very much. Well, I would like to thank all the guests that they have presented their projects. And I would like to open the discussion, doing a general an open question to all of you. So please feel free to answer the first the one. So my question is, apart from the technological research, because that's where all your projects are focused, what do you think where do you think is the European funding should focus more? Where is lacking? So where are lacking some resources? I mean, for example, in building health evidence or raising awareness, or maybe developing quality management protocols for the public administration. So apart from the technological area that, of course, you are all really involved, where is lacking the European funding? Where do we need more resources? So please, the first that would like to answer, feel free. It's really open question, but I hope anyone wants to start the discussion.
Maybe I could go. Yeah.
Yes, of course. Who said?
Yeah, maybe I could.
France? Yeah. Okay.
Yeah, yeah, please. I hear echo, but okay. So where do you need the money go? I mean, we have to develop sensor systems which are sensitive enough that people that we can measure changes. Our projects are mostly focusing on very high levels, not environmental levels, which is long-term greenhouse gases or so, but more on which are immediately dangerous for human life and health. So these are really at high ppm levels, can be sometimes really at high ppm levels, and for this, the sensors can be much cheaper. So I think if you're really concerned about communities near factories and or harbors or so, then you should really try to focus on that type of sensors.
Thank you.
That was my comment there. Yeah.
Thank you, Franz. Thank you. I don't know if anyone wants to participate, say something else, or give another point of view. Yes, Esther?
Well,
oh, sorry. Oh, Joanna, please.
well, it's just a comment. Well, from my point of view, it's not only problem of the resources, it's a problem of putting the science into policy. So I believe we need more projects that will transfer the scientific knowledge into operational applications. So I believe this would greatly help.
Thank you, Joanna. Very interesting. Esther, what would you like to?
Well, I wanted to say that, well, I think that the European Union is investing money in what is called high excellent science, no? In this pillar, what they call it pillar, they are investing money in developing new materials and more directed to improve the capabilities and the challenges for the sensors themselves. Mm-hmm. And there are this second pillar in which you are supposed to have reached a kind of mature technology, and you are able to put it in field, to demonstrate or to make pilot tests, to see which are the real performance in real scenarios. What I think is that normally from my experience in these kinds of projects where there are so many different actors coming from different fields and having different purposes in terms of the kind of organization they are, there is a lack of, interaction, I would say, or a lack of, from ones to understand the challenge and the problems of the others. So that makes more, I think, in my opinion, more difficult to go further into policies, for instance, no? Because there is a way from going to the sensors to the policy, a long way, and all the institutions and the actors that are necessary to reach this final policy need to be really well understood which are the purposes and which are the challenges and which is the kind of work they do. But sometimes I find not much motivation from some actors to understand what the others are doing or which is the final thing we are focusing these projects. So this is but I think they are spending a lot of money also in this collective awareness. Now the European Union has in the age 2020, like Captor, I think there were many, if you look at the EU database on projects, you can see at least 10 on collective awareness platforms related to air quality monitoring. So I think they have put a lot of investment in approaching the air quality monitoring and to improve the knowledge and even the participation of the citizens in this activity. Okay, I think that also, of course, the citizens, the society needs to be involved at some point. I think it's a good point.
Thank you, Esther.
I'm Jose Maria. I totally agree with Esther. I think that also how to bring the low-cost sensors to the monitoring networks, because there is people that they are not believing that low-cost sensors can bring something to the monitoring network. So we have the reference stations and the reference data, and we have a lot of people working in low-cost sensors, but there are also how they can help in some policies or to arise awareness to the people, or what can they give to the reference monitoring networks. And this is not clear. There are some people that believe in them, a lot of people that they don't believe in them. So we have to be sure that they give accurate data, of course, but what are the purpose of these local sensors in the monitoring networks in the future?
Thank you very much, Jose Maria. I don't know if anyone else would like to give any comment about this topic, or if not, Ivana, I think that has, we have, oh, sorry, Stefan. Yes.
Yeah. So my opinion, actually, I see that there is missing the awareness of air quality in general around the people in different countries. Of course, this differs from country to country, but I believe that the corona crisis right now has increased the awareness. So this helps a bit in this topic, but still, I believe we have to work here more, and authorities could help us here a bit more to increase the awareness in general.
Mm-hmm. Thanks, Stefan. Thank you very much. So I think we will go to the questions from the public. Ivana?
Yeah, sure. Please. Thank you, Olga. We have several questions. And that one I'm going to save for last. And yes, how can we value and apply the levels of exposure to certain pollutants using experimental data obtained from sensors? So which are the references we should take?